So just locally, the robots we're using are called FANUC Robots. And this is PHB in Fairview. They do die casting. This is the housing for a Cummins diesel. So if you've ever seen a Cummins diesel out in the road, they make all the housings, about 100,000 of them a year. This particular cell is a 3 FANUC cell. This used to be 4 people's jobs that made about $25 an hour, and now this has been completely replaced by this robot operator. These take these out of the die cast press, bring it over here, trim off all the excess material, bring it over here, test and do all the quality control, and then stack it. The cost of these robots was made up for in the first year at PHB in workman's comp claims. This die cast weighs like 80 pounds. You grab it, you bring it out, you blow out your back. So they made their money back in workman's comp claim in the first year. This is Accuride over here on the east side. Used to be Kaiser Aluminum. They replaced a whole line. So that's an $11 million investment they made in FANUC Robots there to replace a whole line. So that's just some local, in case you were not scared enough of robots and have watched the Terminator movies. This is the Ford plant. Got to get a sense of how many FANUC robots are on just the bed assembly line. So this is welding. This is robots, building robots that build robots. So that's straight Terminator. The robots build the robots at the robot plant. And then our paint division over here. These are the FANUCs. It's just an end of tool instead of a pick and play. Put a paint tool on.
No paint and stuff.
So they're not coming, they're here.
What was the power?
Yeah, I thought so.
So we'll get started with the next lesson. So, we already did safety. We've already talked about the DCS system. We've talked about faults and clearing them. So, we've done a lot of things and we haven't really got a chance to touch the robots much. So, the next step is to understand how to move the robots. So, by the end of this lesson, you're going to know how to jog or move the robot in 2 different ways. And those 2 ways are important because they're key to almost everything else we're going to do. If you understand about robot position in world frame and joint frame, then you understand the 2 different ways we express positional data on a robot. So by the end of this lesson, you should know what is a world frame, what is a joint frame, what is world position, what is joint position. So, obviously I want to move the robot, and I want to know where it's at. That's really the key to what I want to know. I want to move the robot, and I want to know where it's at. So, everybody in here is bright, we've all got degrees. When I want to know where something is at, right, it's there. How do I know where it's at?
X and Y.
X and Y, right? So I've got X and Y information. X is this way and Y is that way, and I go over 6 and I go up 10 and I say that's at 610. What do you call that? Way back when, I know it's a big stretch, back in high school or early college, what do you call that system where you know where something is with X's and Y's?
Coordinate.
What kind of coordinate system?
Cartesian.
The Cartesian coordinate system. So, Cartesian coordinate system is very important to us. We use those words all the time. But in our world, this is the two-dimensional world. Our world is always a three-dimensional world. So we use a three-coordinate system, Cartesian. So if I say it's in Cartesian, you're looking for three numbers. You're looking for X and Y and Z. So, when we're in world, we're in Cartesian, and we're moving linear. Those things all go together. So you know that if I put 2 points out here, a point here and a point there, I could draw a line between those points. For you guys here in school, you would call that Algebra 1. That's linear, it's line, it's on one plane, right? We deal with linear movement. Linear movement is moving from one spot to another along a line. Linear movement uses a Cartesian system, which uses X, Y, and Z. Make sense so far? Okay. Come on over, we're going to do a quick little demonstration.
I'm going.
So obviously, these are our FANUCs. Here's our little representation. This is some point in space. Could be here, could be there, could be there. It's anywhere in this space. How do I know where it's at in space? So if it is right here, from the intersection of my waist and body, right here, the intersection of X and Y, that is my order. That's my abscissa. That's my origin. Origin's a really important word to everything else we're going to do. This is our world origin. This is the robot's world. Just like your world is basically wherever you are. So if you move around, your waist stays there. Like in wrestling, right? You don't look at the eyes, you look at the waist. Because where the waist goes, that's where the body goes. Right? Same with your robot. This is its waist. This is its origin. This is its 0, 0, 0. It's not going to move. It's always going to be here. We're going to use a right-hand rule. Right-hand rule is when you take your hand like this, and you say, from my waist, going this way is the X. Going this way is the Y. And my thumb going up is the Z. So from here, I could say that this is 1, 2, 3, 4, 5, 6, 7, 8 forward. And I could say it's 1, 2, 3 to the right. It is X is 8 and its Y is 3. So if I move this up to 8 and over to 3, I'm pretty close to where it's at. But I could be at any Z there. So Z-wise, this is at 8 inches. So let's say that this is 8, 3, 8. There it is. I'm at 8, 3, 8. X8, Y3, Z8. Make sense? Okay? We express that lots and lots of times. What is its X, Y, and Z? Unfortunately, it doesn't stay that simple. Because I can be at that particular position from any number of orientations. In other words, later we're going to be talking about frames. This particular frame will be called the TCP, or tool center point. Don't worry about that now, but right now, that little tip right there is at, what did I say, 10, 8, 3, right?
8, 3, 3, 8.
What is it?
8, 3, 8.
8, 3, 8. It's at 8, 3, 8. So that little tip is at 8, 3, 8. It's still at 838. It's still at 838. There's an orientation that also goes into this. The orientation of this tip is 3 more coordinates. They are, as I look at my x, y, z, my coordinates, right? This is my z. If I rotate about z, that's my roll. If I rotate around x, that's my yaw. If I rotate around y, that's my pitch. So I have x, y, z, roll, pitch, yaw. So any particular place that this robot can be in the world is expressed in x, y, z, roll, pitch, yaw. When I say where it's at, we're going to look on the teach pendant and say, what's the position? I'm going to press the POSN key. And it's going to say, it's at this x, this y, this z. And then because we already use R, we have WPR. So we don't use yaw is y, but we already use y. So we'd use W. So X, Y, Z, WPR are the 6 positions that you get on a 6-axis robot to tell you where you are. So this has a XYZ and a roll pitch yaw. Same XYZ, different roll pitch yaw. Same XYZ, different roll pitch yaw, depending on the orientation or rotation about the wrist joint. Does that kind of make sense? Okay. So we're going to go back and explain that, but while we're over here, I just kind of want to show you one more thing. There's another way to express where this robot's at. There's the linear way, XYZ, roll, pitch, yaw. And then there's the joint. This is a joint. This joint rotates. When something rotates mathematically, how do we express where it's at rotationally? Degrees. It's at 0 degrees, it's at 90 degrees, right? I could say that this joint is at a certain number of degrees. I could say that this joint is at a certain number of degrees. I could say that this joint is at a certain number of degrees. And then on those, I can rotate this joint in degrees this way, or spin, right? So I could say that it is at joint 1 so many degrees, joint 2 so many degrees, joint 3 so many degrees, joint 4 so many degrees, joint 5 so many degrees, joint 6 so many degrees. Your robot has 2 absolute frame references. It has Cartesian, XYZ, roll, pitch, yaw. That will tell you exactly where your robot is in space. Or it has joint. Joint 1, joint 2, joint 3, joint 4, joint 5, joint 6 in degrees. They are both ways of expressing where it's at. They're both ways of moving. They're both ways of expressing a position in space. Which is better? We use them both interchangeably and go back and forth. So you really have to understand both. The Cartesian coordinate system starts out pretty simple. It starts with a world coordinate system. 0, 0, 0 is here. Then it gets a little more complex later. What if 0, 0, 0 was there? What if 0, 0, 0 was there, and x went that way, and y went this way, and z went that way? So later we're going to get into frames, and we'll define tool frame, user frame, world frame. But for now, we're just going to work with world frame. 0, 0, 0 is at the intersection of x and y at the base of the robot. From that 0, 0, 0, I say what my x, y, and z coordinates are. And then I define my roll, pitch, and yaw. The other way of moving it is joint. I express my joint coordinates of joint 1, 2, 3, 4, 5, 6. Another way of saying the same thing is at any given point, I can be at that point and rotate around x rotate around Y, and rotate around Z. X, Y, and Z are called your major axes. The rotation around X, the rotation around Y, and the rotation around Z are called your minor axes. Your major axes define your position. Your minor axes define your orientation. Clear as mud?
Got it.
Alright.
Can I just use my GPS?
Alright, so let's go to the robot and see how we do it there. I'm going to do it, and you can do it, all right? So we're on. We're in T1. We've cleared all faults. Need our old man glasses. On the teach pendant, holding down my shift key, and I'm going to jog the robot. Hey, am I going to jog the robot in joint or in world? What would be the difference?
The point that moves. It moves from here, it moves from one of the sides.
Sort of, yes. If I jog in joint, I'm going to be changing the degrees of the joint. And if I jog in world, I'm going to be changing the X, Y, Z position. And really, the example that comes to my mind, just because I did this for a lot of years, is if anyone's ever watched martial arts. Back in the day, there's two kinds of martial arts. There's hard-style martial arts. It goes like this, right? Goes straight from one position to the next, to the next, to the next. That would be like world frame. I follow lines, very jerky motion. But if I'm going to go from here to here, I don't waste any motion for the tip. It's going to follow a line from here to here. And if you ever watch the late night kung fu movies, right? When they move, they're all doing this kind of number, right? That's like joint. When joint moves, it's going to be using the degrees. Think mathematically, degrees are like circles. The robot moves in circles. The martial arts thing is, hard-style martial arts is very direct. It wastes no motion. Soft-style martial arts is very smooth. It flows from one place to another. Same thing with the robot. When it moves in joint, it flows. The robot's going to move very smoothly and do the things it needs to do. But if there's a thing right here, and you're going from here to here, you know, if I go from here to here, I'm not going to go by that thing. But if I'm moving like this, I hit the thing, right? So in addition to how we express where things are, the way it moves is part of Cartesian versus joint. So I'm going to define whether I'm going to move joint or Cartesian, or whether I'm going to move joint or world. I'm going to move world. So, world. I'm going to set how fast I'm going to move. You see that? This is the speed I'm going to move. And we're going to talk about that later. We're going to talk about what that speed means in inches per minute and percentage, but for now, that's the speed I'm going to move. This is my X. X is moving away from the waist, forward and back. Now, I'm moving in world. So you'll notice that actually two joints are moving, I'm pressing one button. Right? Because it needs to move two joints to make this motion occur. So I'm moving along the X axis, but two joints are moving. If I moved on joint 1, I would only move one axis at a time. I'm going to move along Y. and I'm gonna move along Z. Major axis X, major axis Y, major axis Z. At any given point, I can rotate about X, rotate about Y, and rotate about Z. Roll, pitch, and yaw. X, Y, Z, roll, pitch, yaw. Releasing the dead man switch, have to hold the shift key the entire time.
Sure, okay.
Okay? So, press the center switch, middle level, shift, and reset. All right, now hold down the shift key and move it about X. Move it about Y. What are we doing to the robot? What do we call that when we move it?
Jogging.
Jogging. We are jogging the robot in world Cartesian coordinates.
Do it.
And she's moving the minor axes. So is that Cartesian or is that orientation? She's moving the minor axes. She's setting the orientation. Cartesian, I get to the point. Minor axes, I'm at my orientation at that given point. Shift, reset.
Oh, I have to reset.
Yeah, because you let go of the dead man switch.
Okay. Cool. Nothing to it.
So if you want to show Jill, and Jason, if you want to come over here, I'll put you on this one.
Always.
Okay. Which hand do?
Same robot, different keypad,
Come on.
but it's same concepts.
Okay. Shift.
Shift and reset.
Okay. X is moving. Hit the reset button. There you go. Yep, that's it. Okay. Yep. Yep, both goes, one goes out, one comes in. You're okay. Oh, you let go. You let go of everything. So hit reset again. Okay. Do it again. There you go. X. Back and forth. Okay. And then Y. Go left and right. Y, Z. Reverse. And then Z go. And then arrows will be your roll around X. Roll. This is X, so we're gonna roll around this way. Right? And then Y, right? Y, you're gonna roll around this way. Nothing to it.
I just let go of everything, I'm done.
You let go of everything, you did it.
Oh.
Go ahead, you tell her how to do it now.
Yeah, don't touch yourself.
Come on.
And then switch on the back.
Reset.
Yeah.
And hold the shift, yep.
And then reset.
Camera shot.
Roll. Did you?
So I'm going to release the dead man
There
switch.
you go.
You're going to get default.
Now I have to.
Dead man switch slightly in. Shift and reset.
Doing the same thing.
Hold shift down to reset.
Right, now,
Do I do a shift on me?
yep.
And then X and Y, or X.
Huh?
Like a mathematician.
Yeah, you got it. What are we doing? Jogging?
Jogging. No, I let go so it's done.
Right, as soon as you release the dead man switch, it releases. Okay?
Yeah,
Alright.
watching the joints, yeah.
Slightly pushed in. You know,
We did
shift
everything like
and reset at the same time.
Cool.
Awesome.
Alright, last thing for the day.
Right?
I mean, when they brought it to the
There's a button. POSN, position.
Oh, position, I thought you were pointing out.
Okay? Don't be shy. X,
That's a really long
Y,
cord.
Z, roll, pitch, yaw, WPR. X, Y, Z, WPR, right? So as I move
Where it
it,
is right now?
that's
and
where it's at right now.
X is changing, Y is changing,
What coordinates am I looking at?
X, Y, and Z,
Which are the
Cartesian.
Cartesian coordinates. There's a button right here, joint, right? So I'm looking in world frame, which is Cartesian, or I could look at joint,